So we were discussing this question. So we need a peaks for 92 and 120. So how you can work out this one, nitrogen is 14 plus 2 makes 16. What about this? This will be CH. This is also CH. This is also CH. This is C. This is CH. So, and this is also C. So 1, 2, 3, 4, 5, 6 are there. So 6 multiplied by 12 makes 72. And plus hydrogen, how many? 1, 2, 3, 4. So 6 into 12 plus 4 hydrogen makes 76. So this is 76. We want 9 and 92. So how it will be, like, as you can see, like this part, the best thing is you just divide into parts. This will be carbon and oxygen. So this will be 28. This whole part. And what about this one? CH3 is there. This will be CH2. This part will be, or together if you count, like this will be 15. This will be 14, sorry, not. And this one is 16. This one is total 28. So one of the peak is 92. So which sum is making 92? If we take 16 plus 76, that sum will be 92. So 92 suggests the formula of the species responsible. We need just a formula. So means the phenyl group is there plus, so it will be C6H4 and NH2. And but this should be a plus charge. Why it's a plus charge? Because positive ions can be detected. Or you can also write n, like all of them together, you can also write. Then 120. So 92 plus 28. Like if I add 92 plus 28, that make 120. So the other is actually NH2, C6H4, and then CO. And then don't forget to write the charge on that. Suggest the formula of organic product which would form when the benzocaine is hydrolyzed. So when we hydrolysis, because we know hydrolysis of the ester will produce acid. So means this will break from here, and one of them, like OH will be there. This is one product, and then the other one will form a carboxylic alcohol. So alcohol and carboxylic acid. But we need a formula, so you can just directly write, or you can also show the skeletal formula as well, because they did not say specifically which formula. So you can represent, suggest a formula is there, but not skeletal or molecular or structural. So any formula is acceptable. Then we have procaine, also called novocaine, is a local anesthetic. It contains 13 carbon atoms per molecule. On combustion, 100 grams produces 242.4 grams of carbon dioxide and 76.3 grams of water, and the mass of a nitrogen atom in 100 grams is 11.86. Use these data to calculate the mass of oxygen atom in 100 grams, hence its empirical formula, which is same as its molecular formula. So first, how to find the mass of a carbon dioxide? We have, like it is giving 242 grams. So how much mass of carbon is there? We know, like, one carbon dioxide molecule contain one carbon. So 44 contain 12. So if it is 242.4, how much it will be there? X. So when we cross multiply, this will give us the mass of a carbon in this compound, that is 66.4, 66.1 grams. Same thing from the mass of a water, like one water molecule contain two hydrogen. So ratio is 18 is to 2, the mass ratio. So if we have like 76.3 grams of a water, how much hydrogen should be there? X. So we'll get hydrogen as 8.48 grams. Then what about the oxygen? how we work out the oxygen, like total mass is 100 minus the mass of a carbon, which is 66 point, minus the mass of hydrogen 8.48, minus the mass of nitrogen, which is 8.46. So when you simplify, you get the mass of oxygen, which is 13.55. Now we have, so now we get the mass of each in 100 gram. Like we got like carbon is there, hydrogen is there, nitrogen is there, and oxygen. This was 66.11, this was 8.48, this is 11.86, and this one is 13.55. Now to get the empirical formula, we divide by atomic mass. So we divide uh, 12, 1, 14, and 16. This will give us the actually the moles of each. So this will be 5.5. This will remain 8.48. This will be 0.847, and this also 0.847. Then we divide by the smallest value in the combination. So smallest value in the combination is 0.847. So all of them we divide by 0.4847. So 5.5 divided by 0.847. 6.49 means 6.5 will be there. This is 10. This one is 1. This one is 1 of the values 1.5, 2.5. So what we do, we multiply all of them by 2. So this will be 13 carbon, 20 hydrogen, 2 nitrogen, 2 oxygen. So C13, H20, nitrogen 2, oxygen also 2. So this will be the empirical or a molecular formula of this compound. So there's a structure using a formula you calculated, and the structure formula of the local anesthetic Y given in the okay. So it is given in the beginning of the question, the structure of Y. Local anesthetic. Yeah. So this one is given to us. So using this, our molecular formula C13, H was 20, N was 20 over, N was 2 and O was also 2. That was our molecular formula. Because I mentioned empirical and molecular formula is same for this compound. So they give us a hint, like we have to just arrange. The only thing we have to arrange is the carbon, because the carbon which are attached with nitrogen. That, so how many we use? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 here, 7, 8, 9 are used here. So out of 9, how many we are left with? So 13 are there, so we are left with 4. So I can say C2 means, if I'm doing a skeletal formula, then 1, 2, and then 1, 2. Sorry. Now this will be 1 and 2. This will be the skeletal. If I'm drawing the skeletal, if I draw the structural formula, then I should write. So this is a question 6 related to aromatic compounds and arenes. Sorry, question 5, not 6. Question 6 is, next question is 6. This was question 5.